In the next half hour, I will show you what you can gain from combining the spreadsheet program Excel and the statistics program R. In the following demo, I will try to show the different options of combining a spreadsheet with R. Underlying the system is the possibility to transfer data from the spreadsheet to R and back, and to run R commands or R functions on the data after transfer. To show the facilities, I'm loading one of the RExcel demos right now. And we see a short explanation. One of the things one can do is selecting a range here, and the range is containing some R commands. Now we can run these R commands. The commands created a matrix, so by clicking on another cell and getting the value from R, we immediately get the result back to Excel. To transfer data from Excel to R, we just select a region, right-click, and put the data from Excel to R. We have to give the new R variable a name, and the data are transferred already. Now we can execute a command operating on these data, and now we want to get the result back. Right-clicking into a cell and getting the variable ZD will immediately bring back the results. The solve command or function we just executed computes the inverse of a function in R, of a matrix in R. This is the raw transfer method, or the raw mode of using R within a spreadsheet. It essentially only has three operations: put data, run commands, get data. With these commands only, you can do everything you want to do. Statistics mostly deals with larger set of data, and especially data frames, meaning a list of variables. So let's switch to the data frame here. The very first thing we want to do is we select this data frame, and we transfer it to R. We choose a name for the data frame, which is the name of the workbook, and we transfer it immediately. Now we can perform some statistical operations. Here is an R function predefined. So we go into this cell here, we get an R value, and we get the expression for the R value from a cell here. And now we can run the command, and we got the means of the weights, of the sizes of the people in the data frame separately for male and female. So again, this is just raw mode, data transfer and computing results and getting the results into the spreadsheet. What we have seen right now was the expert mode of using R. In a spreadsheet, we had to use the full power of the language and the command structure and so on. Now we will see a short example which works differently. So I'm loading another demo here. And this demo has a toolbar added. So all I have to do is I have to click on the button Here I get a small dialog box telling me what's going to happen, and the click of the button brought some data to R. In the background we were running R, but the user didn't even notice. We just pressed the button and got some results. Creating R commands embedded in Excel menu items is rather easy with our toolkit. All the code that has to be written is shown here. It's just this piece of code here. We are creating the message box, we are starting the server, we are running an R command, we are running another R command, and we get the result back to R. We also could stop the server right now, but since the demo is going on, we will do something more. But we will talk about the option of stopping the server a little bit later. Now let's go back to our spreadsheet. To be able to use this kind of interface, all we have to use is this very small set of functions here. We can start and stop the server. We can run some code which is strings in VBA. We can put and get arrays, and we can put and get data frames. And we also can run an R file if we have some R procedures predefined already. It's possible to use them in our framework. Here is another example showing how the buttons work. We have a data set here, and we want to create the regression equation using R. So this is the model statement. In this case, we are using a pre-recorded macro or a programmed macro. We just press this button here and we immediately get the regression coefficients. What's the command behind this button? Now let's look at the code. All we had to do is execute these few statements here. Starting the server, putting the data frame from a region of Excel into an R variable, and then run the R command, producing the result, and putting the results in a range in the spreadsheet. So it's really simple to create a custom application using R as the background engine. We also could add the command stop server here, and if we do that, we see that this is the whole program, and there is no need to keep the R process going or have the R process remember data the user sent. This is a completely self-contained program, so one could start an R server, do the computation, stop the R server, or just use a running R server and then clean out everything after it has run and give another user the option to use the same R process, which is rather important in a server-based environment where you probably want to have a pool of R servers and users should be able to use them just for short time periods to do some computations, and then these servers should be released once again. So far we have seen two modes of combining the spreadsheet with R, but there is a third one, an even more powerful way of combining the power of the spreadsheet and R. So we are loading a new worksheet here, and what this worksheet contains is some new R functions, and we will discuss those functions briefly. REval is a function which takes an expression like this one here and computes a result. Now this is a very easy expression, and it doesn't use the full power of the spreadsheet because it's a fixed expression. Here is something more complicated. We are using a string function to create an R expression. In this case it's a very easy one. We are multiplying the contents of A5 and B5 and we get the result. The important thing is that whenever we change the contents of one cell here, the result cell also changes, and this is not an Excel operation, since we see here that the function RExcel is called. So what we are doing is we are using the spreadsheet to call R to do some computation, but the spreadsheet knows that when the input cells to this R expression change, it has to recompute the formula value. Using this technique we can do even more complicated examples. Here is a function definition contained in R. So here this range defines a function myFun. Now here we are using a new R function, RSetAval, which takes the function name from the blue cell here and the function definition from the green cell here. We will use this to compute the value of myFun when applied to the value of 3. So here is the expression. This function computes the value myFun applied to 3. RApply is a function whose first argument is the name of an R function and whose second argument, or possibly further arguments, are arguments to this function. So of course if we change this value here, the output immediately changes. But what we can do here is even more impressive, because we can change the function definition of myFun on the fly, and immediately the computed value also changes. So what we are gaining here is we are using Excel or another spreadsheet as the container of our data and function definitions, and Excel by its formula mechanism does all the bookkeeping on dependencies. So whenever anything changes, Excel knows which other things depend on the things we just changed, and therefore recompute all the other values. This really means that we are combining the full power of R as a computational engine and the full power of a spreadsheet as a program keeping automatic track of dependencies and recomputing results whenever necessary by looking at the dependencies. We combine two radically different computational models, and so we get a new kind of application. We have the basic ideas of a spreadsheet and the much more powerful idea of R as a computational engine. Here is another example using the recomputation facilities. We have two statistical variables, XVAR and YVAR here, and we want to compute the significance value of the test for correlation. This cell here uses RApply for a component to compute the correlation test, and especially the p-value of the correlation test, and the further arguments are indicating the data up here. So if we change the input data here, if we go to this cell, it's containing random numbers. If we put another number here, we see that the results immediately change. So we have this very powerful computational model that whenever the input changes, the output is recomputed automatically. That's not what R does by itself, because R has a strictly sequential model of computation. Here we might say that we have a full R process living in any cell, in each single cell of the spreadsheet, bookkeeping the dependencies by the spreadsheet, and whenever needed, the special copy of R in the spreadsheet starts and recomputes the results. We will now look at an example demonstrating the full power of combining a spreadsheet and the computational power of R. This example has some data here. This is a column with 1000 numbers. We are using an R function to compute the kernel density estimator for these data, and the Excel graph here, this is an Excel graph, not an R graph, shows the kernel density estimator. Now, a very important parameter for kernel density estimators is the window width. This number here is the window width. What we can do is we can change the window width by moving the slider. So we are changing a parameter for a statistical computation. What's happening is that whenever we move the slider, the parameter in this cell changes. The formula here knows that it depends on this parameter, so it recomputes all its values. But it's an R formula, therefore Excel calls R to recompute the kernel density estimator, and we immediately get back the results. So whenever the slider is moved here, Excel triggers a new computation in R, and this shows that the connection between the processes is fast enough to get real smooth animation. One could not easily get this kind of graph in R. It's possible, but you need to use a GUI programming toolkit, whereas in Excel, creating animated graphs with sliders is a technique which, once you have learned it, takes only 30 seconds to set it up. So here we combine the full computational power of R for computing kernel density estimators, which is highly complex, with Excel's facilities of recomputing and updating charts depending on cell values on the spot. Let me briefly summarize what we have seen in this short demo. We saw three modes of combining a spreadsheet and R. The first mode is raw mode. The spreadsheet is just the data container and possibly the container for some pieces of code, and we transfer data from and to the spreadsheet, and we do computations by running some code in R. For this kind of usage, the spreadsheet has to be connected to one R process for all the time you are using this interactive mode. So if a user would use this mode for an hour session, this user would need his or her own personal R process for the full hour. Until now, we have nevertheless left the Excel worksheets. All we did was working with data in the worksheets and run programs in the worksheets, or little VBA programs. We now want to show how R input and output, and especially R graphics produced in different windows, not the Excel windows, can be captured in the spreadsheet context. To be able to do this, we open a new worksheet and we start an R add-in. There is a program called R Commander which essentially puts an SPSS-like interface on top of R. So we get pull-down menus for a lot of R functions, and we start R Commander. It takes a little time, but we see that here we have the additional R Commander window, and here within R we have the R Commander menu. Plain R Commander would have the menu up here on the R Commander window, but our extension integrates this menu and turns it into an Excel window. So now we can load a dataset from the packages, and from one of the demo packages we choose the chick-weight dataset. Here we see that the chick-weight dataset now is the active dataset in R Commander. If we want to see this dataset in Excel, we just select the cell and get the active data frame. Here are our chicken data. We see there's a weight variable, a time variable, different chicken, and they had different diets. We will now use the R Commander menu to produce a chart from this data set. We go to the Graphs menu and we choose Scatter Plot. We get a menu which helps us to create a moderately complex R plot. So we choose time for the x-axis, weight for the y-axis, and we do all the plots for the different diet groups for the chicken. And now we let R produce our graph. Here is the R graph. This graph does not belong to Excel at the moment. So here is our graph. But if we would like to have it as an Excel graph, we just select an Excel here, cell here, and we have a new menu item, Insert Current R Plot, and the chart immediately is embedded in R. And now we have a chart produced by R embedded in Excel. This chart does not follow the automatic recalculation model. If we were to change some of the data here, the graph would not immediately change. But since these data are considered to be results of an experiment, that's not a very likely situation. This example shows that visual R extensions, GUI extensions to R, written by statisticians to make the use of R easier, can be embedded in Excel, in the RExcel extension also. So part of what has been done to make R easier to use is directly imported into Excel here, and we also see that we can put a menu-like structure with complicated methods directly into the spreadsheet. Furthermore, we also saw that graphical output originally produced as an R chart or an R plot can directly be imported into the spreadsheet. Let us go back to our original demo and try to summarize what we have done. we also can close our commander to go back to the original Excel only state. In the R commander example and in the original raw mode example, we kept data frames or data in R and then used some functions or procedures to get results into Excel. So we more or less assumed that we own an R process for the full duration of the session. In a multi-server based environment, this is not a very reasonable way to set things up. But we had two other ways of using R in the spreadsheet. The second way was to use prefabricated macros to execute some R code. So we could set up a new menu system within a spreadsheet which offers basic statistical methods, and selecting the data and using some menu items to do some computations would do what we need, and the user wouldn't even notice that R is working behind the scenes. Set up the right way, R process would only be needed for the execution of one of the mini programs hidden behind the buttons with the macros, but after running such a program, the R process could be decoupled from the spreadsheet which used it. The even more powerful approach is using the spreadsheet formulas to call R. If the formulas are just plain function calls, each single call needs an R process only while it's computing its results. Therefore, an R process would only be needed if the spreadsheet decides that a certain cell value has to be recomputed. Since the formulas are doing the automatic bookkeeping, or the spreadsheet is doing the automatic bookkeeping, it would also refresh any function definitions or variable definitions needed to perform a function computation. Therefore, in this model, when Excel has finished its computations, the R process could be decoupled from the spreadsheet. In computer science language, we could say that we can use a stateless R process to perform the computation called upon by the spreadsheet formulas. So